In this video, we focus on exercise 19 from section 1.2 of the text. We're given a statement, namely that if A divides the sum of B and C are relatively prime, then that implies that A and B are relatively prime and A and C are relatively prime. So we first want to start by proving that A and B are relatively prime. So to this end, we're going to let D be a common divisor of A and B. Our goal is to show that if we pick some arbitrary common divisor of A and B, we're calling it D here, well then that D has to be equal to 1. So first, what information do we have? Since D is a common divisor, we know that it divides both A and B. So by definition, A is equal to D times S, and B is equal to D times T for some integers S and T. We can also say that since A divides B plus C, that B plus C is equal to A times some integer K. Now if we look at this last equation, we can rewrite it by subtracting B from both sides to get that C is equal to AK minus B. So we have the following. We have that C is equal to AK minus B. If we substitute for A here, we're going to get that DS times K, and then if we subtract B and substitute for B, we'll have a dt. So substituting, we get AK minus B is equal to DSK minus dt. We can factor a D out of both of these terms, and we're left with the following. So suppose that we let SK minus T be L for some integer L. We've shown that C is equal to D times L for some integer L, which is precisely what we need to show that D divides C. So now we have that D divides A, D divides B, and D divides C. But if D divides B and D divides C, and B and C are relatively prime, well that means D has to be 1. If two numbers have the greatest common divisor of 1, and we have an integer that divides both of them, that number has to be 1. So we've shown that D equals 1. So A and B are relatively prime. This is because we picked any common divisor of A and B, and then we forced it to be 1, which implies that the greatest common divisor of A and B has to be 1. So it remains to be shown that the greatest common divisor of A and C is equal to 1. So to this end, should note that B, C, like we just mentioned, the greatest common divisor of B and C is 1. So by Bezout's identity, we can write 1 as a linear combination of B and C. Then we get the following equation. We have that 1 is equal to bx plus cy. And then if we go back to the fact that b plus c is equal to a times k, and this time we subtract c, we can write b as ak minus c. And then we can also keep cy the same. Okay, so what we can do now is just distribute. We'll get akx minus cx plus cy. And we can factor a c out of the last two terms here. So I'm going to write it like this: a times kx plus c times negative x plus y. So if I let kx be m and negative xy be n, I've shown that 1 is a linear combination of a and c. This implies that a and c are relatively prime.